Good morning, friends. Today's class will discuss about page replacement and following page replacement algorithms. What is a page replacement? Why it is very essential in virtual memory? In virtual memory, physical memory is the space of the physical memory is shared among several processes. Example P0, P1, P2, P3. Each and every process uses a number of pages. P1 uses its pages and its own page table. P1 uses its pages and it generates a page table. And P2 uses a pages and generates a page table. P3 uses a pages and generates a page table. All these processes to execute concurrently in multi-programming environment, they need to load their pages in this physical memory, where physical memory space is limited. It should be shared among all the processes. Okay? When a page replacement is required is when all these frames are full. All these frames are full. A particular process wants its page to be loaded. For example, 1, 2, 3, 4, 5. Only 6 frames are there. Only 6 frames are there. Suppose P0 is using 10 frames, P2 using 10 frames, P2 10 frames, P3 is 10 frames. Out of 10 frames, suppose P0 using 2 and this is using 2, this is using 2. It means only P0, P1, P2 can access this physical memory. Since 8 pages right now it is not using. P1 8 pages right now it's not using. P2 right now it's not using 8 pages. Suppose see that only this 2 is P0, P1 and P2. So this memory, physical memory is full. Suppose process P0 want out of 8 pages, 0 to 7 pages, or P0, P1, P2, P3, P4, P5, P6 and P7. Out of these, P0, P1 pages are used by process P0. Now, a process P0 wants any one of the page. Since that particular page is not available in the main memory. Then how to solve this? Since there is no space in the physical memory is filled with all these frames. These frames are filled with particular pages of particular process. Then we need to replace any one of the process page. Suppose P1, P0 needs page P2 to be loaded. This is P0, P1 of process P0. Suppose process P0 needs P2 page, then any one of the page has to be replaced. It has to be removed from the main memory and sent back to the secondary memory onto the disk, and in the disk process P0 page is available that has to be brought to the main memory. Then how you remove a particular page from the main memory of some other process page? Then we need a page replacement algorithms. There are 3 to 4 algorithms. We will discuss that algorithms in the coming session. Understood? Now let us have a small two problems, then we'll go further how we are going to do page replacement. Note down the problem statement. The problem statement is like this. 40 frames. Example 1. There are 40 frames in main memory. Each process needs 10 pages. Each process needs 10 pages. Okay. Each process needs 10 pages means 4 processes can run concurrently. 4 processes with 10 page capacity. Suppose this is a main memory 02 and so on 39. 4 pages, 40 pages. Each process 10 pages. Only 5 pages are used. Out of 10 pages, 5 pages are used. If each process 10 pages means how many processes can execute? 4 into 10, each was 10 pages, right? So 40 frames are required. Okay, but in multi-level programming, each process at present using only 5 pages. Only 5 pages are using. It means only 5 pages means 40 by 5 pages is equals to 8 process can execute concurrently. So we can add 4 more processes into this main memory. Understood? If it is each process needs 10 pages, then only 4 processes. If it is each process needs right now only 5 pages, then we can load 8 processes. It is called demand paging. Using demand paging, right now all these 10 pages are not required. Right now they need only 5 pages by each process using demand paging technique. Now, and same main memory can be used by 8 processes parallel. This increases, my dear friends, multi-programming. Multi-programming gives more allocation or over allocation. Now this entire memory is allocated by 8 processes. 8 processes into each process needs 5 pages is equals to 40 pages is loaded into 40 frames. Well done. So the main memory is completely packed. Out of 8 processes, any one of the process needs an extra page. Can we able to load into the main memory? It's not possible, my dear friends, because this memory is filled with 8 processes, each process in 5 pages. Then if any one of the process needs one more page to execute, to complete the execution, see, existing page has to be removed from the main memory using page replacement algorithm. This is one example, the practical example why we need a page replacement algorithm. Then you may ask the question, then sir, why to give 8 processes to be loaded into the main memory? To increase the throughput of the CPU. CPU, any number of more number of processes if you give to the CPU, it executes concurrently and it gives a better results for us. Okay. Next example, let us see. Example 2. Example 2. 6 processes. I taken example 2. 6 processes. 10 pages they need. Means how many? 16, 6 into 10, 60. So 60 frames we need. Okay. Let us see. It uses only 5 pages. 5 pages. Okay, my dear friends. So total frames are in the main memory 0 to 39. It means 40 frames. Okay. Actually 60 frames needed, but we have only 40. But 6 processes, each process right now using 5 pages, means 6 into 5 pages is equals to 30 pages. 30 pages are right now filled. 30 pages are filled. 10 pages are empty. In the main memory, 10 pages are empty. If a case occurs that all these processes, 6 processes at a time, they want their 10 pages to be loaded into the main memory. Is it possible? The main memory size is only 40 frames, but at a time 6 processes want to load their 10 pages. So requirement is 60 pages, 60 frames, but available is 40 frames. So what we can do? There are 3 options, my dear friends. Option number 1 is we can terminate the process, any one of the process, 6 processes. Option 1, we can terminate any one of the process. If you terminate that particular process, 10 pages will be removed from the main memory. Option 2, any one of the process to be swapped, should be sent back to the main memory, so that from here you can allocate the space. The third option is replace a particular page. Okay. In our classes, in the next classes, we will see that how individual page is replaced. That will be continued in the next session. Okay. Now, basic page replacement will be discussed now. When main memory is full, on how we are going to replace the particular page. Okay, my dear friends, look at the. If main memory is full, this main memory is full, process P0, it want its page to be loaded into the main memory, but this is full, no space, maybe occupied with other processes pages also. Not only the entire memory, it's not only occupied by the single process, it will be occupied by the several other processes. Okay, so P0 want to execute, it want to load of its one of the page. That page is available in secondary memory. How it is going to load that? This is which process, which page is full, which page is empty. We will maintain a small table, page table. Page table has the frame number and valid invalid bit, valid invalid bit, like this. Find out the page where it is located in the main memory. Find out the page and see that is there anything free space in this main memory. Free frame is available or not, we have to check. If it is not available, then apply page replacement algorithm. Using page replacement algorithm, we need to remove this, any one of the, let us say that this first frame, it has to be removed. As soon as you removed this, valid of this one should be invalid, and whatever the page is requiring, this is actually previously is invalid, it's not available in the main memory, then required page has to be loaded. As soon as you load, then you convert into this is a valid. So particular frame is available in the main memory. Like this, we'll replace the page table. Let us see the hardware architecture and we'll follow step-by-step procedure. Can you follow this? This is a page table. One is I, one is V. This is the main memory. Victim, secondary memory. Victim has to be brought to the secondary memory. A new frame F has to be brought to the main memory. Okay, my dear friends, if you see this, first we did swap. First part we did is victim has to be which page you want to replace. Generally we replace an unused page for the long time which is in the memory, that will replace with the incoming page. Suppose this page, victim page, it's not used from the long time, then it will be removed. As soon as it will be removed, it will be, this page will be invalid. Number two. Number two is update the page table. As soon as after that, in the free space, you need to load a particular page frame F. F is loaded here, frame, and now this is available in the main memory. We update with this valid bit. Valid invalid bit. Valid means this particular frame F available in the main memory. Here page O is not available in the main memory, that is where we kept invalid. After that, now for the particular process P0, its required page is available in the main memory. Then process again restarts its execution. This is the page replacement architecture, my dear friends. Understood? Now, based on this, we'll do one small algorithm, first in, first out algorithm, and we'll see how this works. Okay? Now, we'll continue the class. We'll discuss now about what is a reference string. A reference string, a memory references. A memory, how many times a memory references which page it is referencing. See, memory always, millions of memories are there. Millions of bytes, millions of locations. So it is very difficult. Then we'll using the page size, then we can reference, yeah, which locations a process is pointing to access the particular data. Let us see one example. It's a reference string where page size is 100 bytes per page, and its memory reference is like this, my dear friends. Please can you note down 0100, comma 0432, comma 0401, 0612, 0102, 0103, 0104, 0101, 0611, 0102, 0103, 0104, 0101, 0610, 0102, 0103, 0104, 0101, 0609, 0102, 0105. My dear friends, a process referenced these memory locations. These are the memory locations. From this we'll find a string, memory string, based on page numbers. See, like this individual to the 100, immediately 101, 102, so many memory locations. But for simplicity's sake, we'll take page size is 100 bytes. So in 100, using with 100 bytes length of the page size, now we'll calculate how a process access page numbers. Okay. Now let us see. This is 1, page 1, 100, 200, page 2, 300, page 3, 400, page 6, like that, and so on. Now here, this will be accessed with page 4, and this will be accessed with page 1. This is accessed with page 6, whereas 101 to 103, 104, 101 up to here, page 1. Here, page 6. Here again, up to here, page 1. This is 600, right? Page 6. Again, from 102 to here, page 1. This is page 6. This is page 1. Now, this is, my dear friends, this sequence is called memory reference string. These are all called page numbers. Okay. The process wants page 1, page 4, page 1, page 6, page 1, like this. This is the actual memory how I converted by using page size 100 bytes. Okay. Now let us do one problem, my dear friends. First in, first out page replacement algorithm. First in, first out page replacement algorithm. Here in first in, first out page replacement algorithm, I will take a memory string like this: 7, 0, 1, 2, 0, 3, 0, 4, 2, 3, 0, 3, 2, 1, 2, 0, 1, 7, 0, 1. This is the memory string we discussed how the memory string is generated in the previous diagram. I explained how to generate a memory string. This is a memory string. A particular process wants these pages. It means these pages are not in main memory. Main memory have frames, right? These pages are not in main memory. Then we have to find, if it is not available, we have to load this into the main memory. If it is available, well and good. If it's not available in the main memory, it's called page fault. If it is available, it's called hit. If it is not available, it is miss. Okay. Now we'll calculate how many page faults occurs. How many page faults? How many times these sequences are not available in the main memory? Page fault we are going to find out now. Using algorithm, best algorithm, first algorithm is first in, first out. The first in, first out algorithm. Whoever comes first, they have to leave the memory. It means whoever stays in the longer time in the main memory in a particular frame, that frame has to leave the main memory and go to the secondary memory. Okay. Now we'll do step by step. We'll have 3 frames in the main memory. There are several frames. For our simplicity, we'll take 3 frames. That is F0, F1, F2. 3 frames I taken, my dear friends. 3 frames. Okay. Let us follow. Yeah. First 7. Process wants page number 7 in the main memory. It is not there in the main memory. Then load it in page 7. Good. This is completed. This is completed. Next, my dear friends, process 0 has come. Load that process into frame 1. So in frame 0, 7 is there. Frame 1, 0 is there. Done. This is also completed. Now process 1 has come. Then load into page 2. This is completed. Sorry, process page 1 is not there. It is also. Now my dear friend, you see, now this process, all pages are full. Main memory has 3 pages. All 3 pages are full. Okay, like this. This is the memory. F0, F1, F2. These 3 are full. Now new page it's want. Process wants page 2. Page 2 is not there. Page 2 is not there means any one of the page has to be removed and replaced with page 2. That is the concept. Okay. Now page 2 has to be, to get into the page 2 into this 3 frame buffer memory, any one of the frame has to be replaced. Our technique is, right now we are implementing it, first in, first out. Whoever came first, or simply you remember whoever in the longest time in the main memory. If you see 7 here, 7 3 times means longest time. 0 here, latest one, 0 2 times. This is only one. So we'll replace with 7. So 2, 0, 1. This is also done. Okay, my dear friends. Now 0 arrived. Now process wants 0 frame. So 0 frame it found here is a hit. No need to replace it. It's got it. Okay, it is available in the main memory. Now next is, my dear friends, Page number 3 it wants. Page number 3, next page number 3, how we will replace is, simple thing is, latest one is 2, right now 2 is only 1. Now 0 is main, how many times? Since 0, 3 times, this is the longest. 1 is only 2 times. So 0 is 3 times, then you have to replace in place of 0 with this incoming frame 3. Now 2, 3, 1. This is done, my dear friends. Now again 0 frame comes. 0 frame. How to replace it? Only 2 is 2 times. 3 only 1 time. This is 3 times. So that here frame 2 will be replaced with 0. 2, 3, 0. This is also done. Now frame 4 has come. Frame 4. Only see how many times? 3 times, 2 times, 1. So we have to replace with F0. 4, 3, 0. Done. Now 2 has arrived. 2. See that 4 1 time, 3 times, 0 2 times. We have to replace with F1. This is 4, 2, 0. This is also done. Now 3. Page number 3. 4 2 times, 2 1 time, 0 3 times. So this is the longest. So 3, 4, 2, 3 is replaced with 0. This is also done. Now 0 process wants page number 0. Let us see page number 0. This is 4 3 times, 2 times, 1. Now it will be replaced with the frame 0. 0, 2, 3. This is also done. Now you see this. Frame 3 process wants that frame 3 is available in the main memory. Hit. Frame 2 wants this is available in the main memory. You don't need to replace. It is available in the main memory. Hit ratio. Now let us see frame number 1. It is 0, 2. How many times 2 is staying? From longer time it is staying in the memory. That is why we need to replace 1 with 2. That is 0, 1, 3. This is also done. Now let us see 2. Page number 2 it's 1. 2 is there, it's not there. Then how to replace? 0 is only 2 times, 1 is 3 is 3 times. Then this is longer time staying in the main memory. Then 0, 1. This 2 should be replaced with this 3, 2. This is also done. Now 0. 0 is available in the main memory. Very good. 1 is available in the main memory. Very good. In the hit ratio. Okay, we can able to find in the main memory. Number 7. 7 is not available in the main memory. 0 is from 3 times from here. 1, 2 times. Now we have to 0, 1, 2. It is done. Now 0. Now 0 has to be replaced. 0 only 2 times. Now 1 is 3 times, right? So that 7, 0, 2. This is also done, my dear friends. Now 1 is there. 1, 2 times, 0. This is 3 times, 2 is 2 times. So 7, 0, 1 is replaced with 2. Yes, madam. This, how many page faults are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So page FAULT fault is equals to 15. So a process 15 times it's encountered its page fault. See, what is our intention? Page fault should be decreased. More, if page fault is more means not efficient. Every time keeping in replacing the existing page in the main memory, replacing with other page, this is a cumbersome process, time consuming process. The page fault or algorithm, page replacement algorithm's main aim is to reduce this page fault. Now using this algorithm on the same memory string, 15 page faults occur. We apply this to other algorithms on the same string. We'll compare how many page faults are occurring. Okay, whether it's reducing or increasing will be discussed in the next class. Thank you so much.